Hello everyone. So, our new topic for today is filter fabrics. So, today we will discuss the details of their production, their application, the materials used, and basically we will start with the theories of filtration. So, what is filtration? So, it is a process of separating one substance from another. So, that is basically the term filtration we mean in general. Now, by definition if we see, it is a process of separating dispersed particles from a dispersing fluid medium by means of a porous media. The dispersing medium can be liquid or it can be gas or a mixture of gases. So, here from the diagram we can see the particles which needs to be separated from the dispersing medium. This dispersing medium may be fluid, may be liquid or may be gas, and the particles are small solid particles, and this is done by one filter medium. So, in our case at present we will discuss the textile filter medium. So, here textile filter medium is there, and here it is a thickness of the material, thickness of filter, and it is of great importance. We will discuss particularly for depth filtration, and in the upstream side the dust and the fluid are fed to the filter fabric, and all these dust particles are arrested by this filter fabric and clean air is coming out. So, depending on the filtration efficiency, the number or quantity of these dust particles are arrested, and the direction, the side where from where the dusty fluids are entering into the filter fabric is known as upstream side and other side is downstream side, and the particles can deposit outside the surface of the filter medium, that is a filter fabric, and it may form filter cake or it can be deposited inside the structure. But in most of the cases both this cake formation and the depth deposition of the dust particles take place. So, this is the channel wall, lower wall and upper wall through which the dusty fluids pass, and the pressure at the upstream side is higher than the pressure in the downstream side, and this difference is known as pressure drop. So, we will discuss all these parameters. So, why do you need filtration? It is required to separate the contaminants from a fluid stream or separate value added materials like minerals, chemicals and foodstuff from fluid stream. So, it has two requirements basically. If we want clear fluid, maybe liquid or maybe gas, free from any dust particle, any particle, then we need filtration. Or on the other hand, if we require to remove or take out the useful minerals or chemicals from a fluid system, fluid mixture, then we separate the fluid and take the minerals, chemicals or foodstuff. So, either we can use the fluid or we can use the mixed filtrate particle. So, in general, if we see in as far as textile filters are concerned, in majority of the cases we use non-woven filter, because of the obvious advantages. It is porous, it has got higher thickness, so that the particles can be deposited inside the structure, and also due to high porosity the pressure drop is less, which in turn reduce the energy cost. So, high energy saving, because due to lower pressure drop. So, energy saving is less, energy saving is high. So, required energy will be less. Let us see why due to non-woven we can save energy. Suppose this is woven fabric. Woven fabric has got specific dimension and the pores, proper structure of pore. Now, any particle, so these are the say pores and these are the solid portion, okay. This is the solid portion, pores, defined pores are there. Now, any particle which is smaller than this pore size will easily pass through the pore, but if the particle is larger in size, then it will immediately block the pores. Once the pores are blocked by dust particles, so flow of air will not be easy. So, pressure in upstream side and pressure in downstream side will be different, and the difference in pressure, that is pressure drop, will be very high. So, to flow the air at this higher pressure drop, we need higher energy, higher energy is required. So, but if we use non-woven fabrics which are much open in structure and the fibers are aligned randomly and the particles smaller, even a smaller particle or larger particle, they can penetrate inside the structure and these particles will be trapped, these particles will be trapped inside the structure without blocking the pores. So, delta P, that is pressure drop here will be much lower than in case of woven fabric. So, we can save energy if we use the nonwoven fabric. So, it has been observed that nonwoven fabric reduces the energy cost. As far as cost of production is concerned, per unit length, nonwoven is cheaper than woven fabric. It is versatile in nature, means we can use nonwoven filter in many applications, be it wet filter, dry filtration, microfiltration, many applications, coarse filtration. So, many applications we can use nonwoven fabric, whereas in case of woven fabric, a particular woven fabric can be used in a particular application. So, it is limited applications are there, and nonwoven can be recycled because it is made of fiber. We can melt and again convert the molten polymer to the fiber and nonwoven fabric. So, the nonwovens can be used in both air filtration or liquid filtration. The filters like engine filter, they include both liquid and air filtration. So, where air and liquid filtrations are required together at a time. So, definitely we have to go for nonwoven filter, otherwise nonwoven is widely used for air filtration as well as liquid filtration. Now, filtration means the removal of particles. So, to design proper filter fabric, we must first know the range of particle size, then only we can separate these particles from the air or water. So, this is the particles which are present in the air and which needs to be separated. Okay. We see the like smog, the particle size is from 0.01 to 1 micron, carbon black it is from 0.001 to say 0.1 micron, like this bacteria within the range of say 1 micron range, okay, it can go up to 10 microns. Similarly, human hair, mist, lint, so pollen. So, these are the different particles which we need to separate from the air to purify, okay, to get the pure air. As far as water contaminants are concerned, the similar dimensions are there, like bacteria, virus it is ranging from 0.01 to 1 micron, bacteria is around 1 micron, okay, parasite. Okay. So, these are the different particles. So, what are the applications of liquid filtration? So, liquid filtration is required to separate various contaminants present in aqueous or hydrocarbon. So, aqueous solution will get different contaminants, or if we want to filter the hydrocarbon. So, this liquid, so that we can get them in pure form. So, the examples are water purification. So, in water purification we have to separate all the contaminant present in the water, aqueous food filtration, beverages filtration, blood filtration, edible oil filtration and fuel filtration. These are the most common applications of the liquid filters. So, liquid filtration may be defined as the separation of solid from liquid, like air filtration is separation of solid from air stream. So, it is a separation of solid from liquids by passing a suspension through a permeable medium which retains the particle. So, like air filtration, So, we need a permeable medium. Here it is a textile filter fabric, and through that fabric only liquid can flow and the other particles present in the solution will be retained. So, here it is a suspension of liquid and the particles. The suspension is flown through the filter medium and the filtrate flows, and this is the driving force, that means it is a pressure drop. So, this is high when the pores are being blocked. The fine apertures necessary for filtration are provided. This is provided by the either by filter cloth. So, for liquid filtration we can use filter cloth, or we can use mesh or screens of plastic or minerals, or sometime we use beds of solid particles like sand beds we can use to filter the cloth, filter the liquid. In some case thin permeable coat of cakes are provided on the surface of the cloth. It is put on the cloth prior to main filtration process. So, this it is actually required to enhance the filtration efficiency of the fabric. Now, we will discuss the types of filtration. So, broadly if we see, the filtrations can be divided into two types. One is surface filtration and another is depth filtration. As the term says, the surface filtration is actually takes place at the surface of the fabric, that is the upstream surface of the filter fabric. Now, from this diagram it is clear that the particles are accumulated on the surface of the fabric. So, use of cake filtration in which the solids are deposited in the form of cake on the upstream side of relatively thin filter medium. Now, here we normally use the woven fabric. When you use the woven fabric, this type of surface filtration takes place. So, woven fabric or so very thin spun bonded non-woven fabric, they are used for this surface filtration. Let us see what happens during the surface filtration. Suppose this is the fabric with holes. Okay. Thin say woven fabric or the spun bonded fabric. Now, dust particles, they are mixture of particles of different size. Very fine. Now, once this particles with the fluid passes through the fabric medium, during this flow what happens, initially the smaller particles will pass through the filter medium. This is filter fabric. But the larger particles will not be able to pass through this. So, they will be stopped. And this will form a layer, although there will be chances where they can block the total pore entirely, but the chances of this type of situation is very rare, because the dimension of the pores and dimension of particles are not exactly same. Like if we take example of woven fabric, so this is woven fabric. So, dimensions are say square, dimensions of pores are square, but if we take one particles, dust particle with uneven dimension, so they will be stopped. I am drawing the top view. So, they will be stopped, but they will not be able to block the pores totally, 100% blockage will not be there. So, here the air can pass, there will be air permeability, it will remain still be permeable. So, like this way this larger particles will be arrested. Now, this is one layer. Okay. Now, still we will find the small particles are passing through this. Gradually there will be another layer over that. So, this is another layer of larger or relatively smaller particle also mixture of, because by the time the opening became smaller. But what happened here, the formation of cakes with largest particle closer to the surface, and gradually this cake will start as extra filter medium, that is called cake filtration, and the porosity of this cake will still remain. So, the air can pass through this, but the particles, even smaller particles, will not be able to pass. So, this total phenomena is known as surface filtration. So, in this way the surface filters work. So, this is the diagram which shows that initially the smaller particles are flowing through the filter medium, and gradually the filter cake formation is there, and after certain time the filtration efficiency becomes very high with proper flow of fluid, and the pressure drop does not increase too much. So, all particles which are bigger than pores are captured on the flat filter surface. So, the surface filter, another requirement is that the filter surface must be flat. It is typical, for example, for woven fabric or spun bond fabric. Spun bond nonwoven and woven fabric, we have smooth surface. Thus, for these fabrics the pores distribution and permeability are important properties. So, pore distribution we must know, like as I mentioned that for woven fabric pores are defined, and for span bond filter fabric we can also measure the pore distribution. So, flat filtration is common for mainly liquid filtration. So, another important issue here is that the flow rate of the fluid should not be very high, and also there should not be any disturbance in or turbulence in the flow, otherwise that turbulence may disturb the formation of cake. So, proper stable cake formation should be there for surface filtration. The second characteristic, second type of filters are, it is a depth filtration. So, here what we have discussed, that is surface filtration, which happens on the surface of the thin filter medium, but for depth filter we need a thicker fabric. This is the thickness, we need thicker fabric, and that is why non-woven filters are used for depth filtration. Another characteristics of non-woven are the pores are not defined, these are randomly oriented and random dimension. The particles, even a very small particle, it can penetrate easily inside the structure. So, this is the particle, it is penetrating inside the structure, but this particle will get trapped inside the structure. This entrapment takes place due to various mechanisms that I will discuss. There are different mechanisms by which these particles get trapped inside the structure within the depth of the, this is the depth of the filter. So, as these particles are trapped and separated from the stream in the inside the depth of the filter medium, that is why this type of filtration is known as depth filtration. Here the advantage is that the pores are not blocked immediately, it is very gradual process and that takes longer time. So, for non-woven filters, if we use the depth filtration technique, so the life of the filter is long. So, use for deep bed filtration in which particles, the particle deposition takes place inside the medium and cake deposition on the surface is undesirable. So, here in this case cake deposition is not required. We can see the depth filters are able to capture particles that are too small to be sieved out. So, in the cake filtration, initially in surface filtration, initially the large smaller particles are that they pass through the filter medium, but in depth filtration very small size of particles are filtered, particles which can be smaller than the distance between the fibers. So, that is the distance between the fibers means the pore size, much lower than the pore diameter, the particles can be captured. So, this capture mechanisms are different, they are captured by different mechanism depending on the size of particle, velocity of the stream. So, that I will discuss in detail. This type of filtration process is important for most of the filtration application. So, surface filtration is important, but the application is limited, but depth filtration is actually you can use in wide application areas. So, this is the direction of flow and particles are captured inside the structure of the filter medium, and some of the particles we can see it is coming out, but that can also be arrested if we change the mechanism. If we change the air velocity or if we change the type of fiber, that capture efficiency we can change or filtration efficiency we can change. Okay. So, filtration mechanisms are, so surface filtration and depth filtration, they are of two types, and surface filtration the mechanism follows is surface loading and cake filtration. So, as I have already mentioned, surface loading means the particles, the larger particles will be loaded initially on the surface and the cake will form gradually, and the cake will act as extra filter medium. Now, let us see, suppose we are trying to use the filter mesh made of say monofilament, nylon monofilament filter mesh we are using. Okay. These are the filter mesh. Here it has got certain size. Initially, and I am drawing the side view. Initially, there will be surface loading with the larger particle, and gradually there will be cake formation with a certain thickness of the cake. This is the cake and this is the fabric, filter fabric and cake formation, and finally this cake will act as actual filter and this fabric, that mesh will act as a support of the cake. So, this is called cake filtration process. So, cake filtration takes place on a very thin mesh. First surface loading will be there, then there will be cake filtration. On the other hand, if we see the depth filtration also has got two stages. First there will be depth loading and then depth filtration. So, this is the surface loading, the smaller particles are actually passing through the pores and larger particles are arrested here, and gradually there will be surface loading. The surface will be loaded with the particles, maybe smaller, medium, even gradually all the particles will be loaded on the surface, and this will form one cake, surface cake, and here this surface cake will act as additional filter medium. But if we see the depth filtration, in depth filtration there will be depth loading. So, in any non-woven filter medium we cannot expect that the pores are straight in nature. Now, we cannot expect this type of pore in any non-woven fabric, where the pores are straight or defined and the particles are passing through. So, in this type only can happen in case of woven fabric and spun bond fabric, and non-woven fabric with high thickness, definitely there will be a point where the pores are becoming narrow. This is called necking point. So, in this place, once the particle is moving, the particle will get trapped at the necking point and will get separated from the air stream. So, first there will be a necking point, and there at this point the particle will get trapped. So, necking point where the pore size becomes smaller than the particle size, and at this point particle is trapped. So, these are the different necking points where particles are being trapped, and this is only possible in case of thick fibrous filter medium. So, fibrous filter medium, the main advantage is that the dimension of filter dimensions of pores are not uniform, they are variable pores, and this can be it is possible only in case of non-woven fabrics. And depth filtration means at the necking point the depth loading is there, and after that once they are getting trapped they will get separated. So, this is different from depth loading. So, depth filtration is different from depth loading as it involves specific mechanism. Now we have to understand the difference between depth loading and depth filtration. So, what we have discussed, I have discussed earlier, this is called at the necking point it is depth loading. So, if we see suppose this is the non-woven fabric. Okay. The particle will be trapped at this point. Similarly, there will be different places where particles will get trapped. So, this is these are depth loading. So, at different points inside the structure of the non-woven fabric the particles will get trapped, but this is entirely different from depth filtration. So, loading is there which is totally physical in nature, but the depth filtration involves specific mechanism depending on the size and the velocity, the capture mechanisms are there, different capture mechanisms are there, which is actually known as the depth filtration. So, what are the capture mechanisms? In case of depth filtration, there are mainly 5 different capture mechanisms. So, through which particles are being captured during the passage through a thick porous medium, thick nonwoven filter medium. These mechanisms are inertial impaction, direct interception, Brownian diffusion, gravity settling and electrostatic capture. So, these are the different capture mechanism. I will discuss one by one in detail. Now, let us see one nonwoven fabric. So, this is a nonwoven fabric, say unit of nonwoven fabric. Okay. Now, here if we see the fibers are, these are the fibers are randomly, and we can see it say this is a say needle punch nonwoven. So, on unit cell of needle punch nonwoven. Now, if we take slice of one portion, top slice. So, air is flowing say from this direction and coming out from this direction, particles are flowing from this direction. So, let me draw small thin slice of single fiber layer, a slice of single fiber layer. Okay. Now, so these are the say fibers, red color I am drawing fiber. These are the fibers randomly oriented, having different pore structure. So, these are the fibers, different fibers. Now, a particle which is say shown by this blue color, one particle is moving, this is a particle, it is trying to move through this thickness, this is the thickness of the fabric. This particle when it is moving at very high speed with the along with air, it penetrated in this is smaller size say particle, and this particle size is smaller than the distance between average distance between the fiber. So, the small particle it has penetrated inside, it is trying to flow through the along with the air. Now, air will try to take its own path depending on the space available. Where there is opening, spare air will try to take that path, but this particle as it is relatively larger in size, this will not follow the air path. So, suppose this is particle and this is air is moving, it is moving with air. So, air is moving, suddenly air is taking this turn, but the particle once it is moving at high speed, this has got certain inertia, this will not bend with the air, this will try to move straight in the path, this will follow its own path due to its inertia. So, as it is not the following the air path, why air has taken different path? Because there was some obstruction. Obstruction of what? Obstruction of fiber. So, suppose at this point there was a fiber present. So, air was obstructed and it has flown in other direction, but the particle did not follow that path, it has actually collided with the fiber surface and it has lost its energy and got settled at that point. So, this mechanism is known as inertial impaction. So, it has impacted due to its inertia. Okay. So, this inertial impaction, if we try to plot, this is particle size micron, this is filtration efficiency. So, filtration efficiency. So, the inertial impaction takes place at certain particle size. If the particle size is less, this inertia will also be less. So, inertia will not be. So, this inertial impaction, this technique will not be, this mechanism will not be followed there, and as we keep on increasing the particle size, this inertial impaction will be more and more, and the chances of particle getting captured will be more. So, that is why, so for certain size, so this will be typically this type of filtration. This is the inertial impaction 1. So, inertial impaction. Next technique is called direct interception. So, again let me draw once again. So, again I am drawing one thin slice of fabric, these are the fibers. These are the fibers. Now, when the fibers are aligned in random direction and air loaded with little bit smaller size particle. So, in this at present the particles are smaller in size and air is say moving through the material, through the filter medium at different direction. So, as depending on the available space, as the particles are smaller than earlier one, smaller size, these particles will have less inertia. So, they will try to bend along with the air. So, this particles will not move in straight path like earlier case. Here the particles will follow the bent path along with the air, but during this bent path, suppose this is a particle, one particle, this particle is moving along with the this air. So, during this longer path, there will be one place where the distance between two fibers are less than this diameter of or size of this particle, and at that necking point this particle will get captured. So, that is called direct interception, it will get intercepted directly on the that necking point, that point. So, direct interception is there. So, direct interception takes place only in case of smaller particle, smaller than the inertial impaction, but the probability of getting this type of particles captured will increase with the increase in size of the particle. So, again for inertial, so direct interception, it will start at the little bit early at lower particle size, but with the increase in size the chances of the particle getting captured will increase, that is called direct interception. Second. Third one is Brownian diffusion. What is Brownian motion? So, Brownian diffusion takes place due to Brownian motion of the particle, and when it is diffused from one surface to another surface during that movement. So, Brownian diffusion is that when the particle moves in random Brownian motion at different direction, randomly it moves, but it can only happen in case of very fine particle. If the particle size is very fine, then the chances of Brownian motion will be high, and as the particle size increases, the Brownian motion will get reduced. So, suppose this is a very small particle, this particle moves in this fashion during its path, and due to this random path there will be a particular point where this particle will strike the fiber surface and get settled on the fiber surface, and this Brownian motion, the chances of Brownian motion reduces with the increase in velocity of air stream. So, Brownian diffusion can only take place where we have very low air velocity and the size of particles are very small. So, at very smaller size particles, say this point, the efficiency will be high, but as we keep on increasing the size, so the effect of Brownian diffusion will be less. There are other techniques, other mechanisms. The gravity settling means the heavier particles, due to its mass, due to its weight, it will get separated from the air stream and will get settled. And electrostatic capture means if you charge the fiber, or if we charge the filter medium. So, any particle which is charged in opposite charge, by opposite charge, this will get attracted and settled on the fiber surface or filter medium. So, these are the different filtration mechanisms. In next class, I will discuss in detail of all these mechanisms and what are their applications. Till then, thank you.